Oh, hello, my name is Denis. I'm part of the HPE Developer Community Program for the team. And I would like to thank you very much to have Jordan Nanos, a distinguished technologist from HPE, with us today to talk about the HPE Private Cloud AI and how people can leverage the HPE Private Cloud AI for fraud detection and beyond. And before diving into this Munch and Learn topic, I would just like to take a couple of minutes just to talk about the HPE Developer Community Program and the offers and resources. So as you may know, we have a set of webinars called Munch and Learn. This is a thought leadership type of talk. We have also a set of meetups that we deliver on monthly basis. It is an in-depth talk about specific technology, product, or solution, not only from HPE, but also from partners and ISV partners. And a few months ago, we recently launched a new type of webinar called AI Jam Series. It is a panel discussions to talk about foundational aspects of implementing AI in an organization. And I will put in the Q&A section of this webinar and the chat section of this webinar the list of links to look at the calendars for all these upcoming webinars, and with a list of registration links for the upcoming webinars in March. As a community, we also offer a set of hands-on labs called Workshops on Demand. These workshops on demand are based on Jupyter notebooks, and they are available to everyone for free anytime. And as a community, you can join our community through our monthly newsletters, or you can also join our Slack workspace and start a discussion on any product and solution from HPE or partners. You can follow us on X or Twitter. And as a community, we also appreciate any contribution from people who are members of the community. So you can submit a blog post. You can also reach out to us to deliver a webinar on a specific technology or product and solution. And you can also reach out to us to work with us to enrich our workshops on demand catalog. You can scan the QR code on the right side of the screen, or you can just go to the developer.hp.com. So you will reach the HPE Developer Community Portal. And from that, you will be able to join the community through subscribing to the newsletters or to join our Slack workshop workspace. You can also contact us through hpdev@hpe.com. And I will put all these links in the Q&A section of this webinar and on the chat. And if you have during the Munch and Learn webinar, if you have any questions, please post your questions on the Q&A section of this webinar. And with that, I would like to get started with this Munch and Learn and let Jordan talk about the HPE Private Cloud AI. Jordan is all yours. Thank you.
Thank you. And hello, everybody. Good morning, good evening, good afternoon. I know from the registrations, we've got people from all over the world and hopefully people watching some of the recording here today. So I'm excited to share with you a little bit of work that I've been doing recently on the private cloud AI product from HPE. I think there's been a lot of focus on this recently from HPE, and it's exciting to be making progress with customers and partners to learn more and help them build their PCAI environments. Okay, so as I go through this presentation, I just want to start by sharing what to expect, what the contents will include, and maybe a quick housekeeping. So I will say that I can see the chat and the Q&A while I'm presenting here. So if you do have questions, please feel free to answer them. We also have some experts in the chat who are who may be able to answer while I'm presenting. But the contents of the webinar look like this. Basically, I'm going to start by explaining how to get started with generative AI in private cloud for AI. We'll walk through what it's like to deploy an LLM as an OpenAI compatible endpoint, how to build a simple chatbot, and that should be enough to get people started. It is the most basic thing that our customers are looking to do. They're basically looking to clone the experience of ChatGPT or Gemini or Claude, but run it in a data center where they have full control. The second piece is to use the same environment for traditional machine learning. So, and by same environment, I mean the same GPUs, the same user access, the same data storage, things like that. Where instead of doing traditional, or instead of doing generative AI stuff, I'm going to do traditional machine learning. I'm going to prepare some tabular data specifically for a auto insurance claims data set with the intention of training a traditional machine learning model to predict fraud, a binary classification, fraud or not fraud. But of course, this is applicable to anybody with tabular data. I'll get into those details. Then register the trained model, track metrics during the training with MLflow, one of the frameworks that we include with Private Cloud AI. Deploy and monitor trained models and build a simple front end, which I'll show you is another thing called an imported framework in PCAI. The final thing is to, step 3 is to build generative AI into a traditional machine learning workflow. This is something I've been working on a lot with customers, partners, which is to say, if a user or a community has experience with traditional machine learning, they may be trying to apply a generative AI model to either predict fraud directly in this case, or provide explanations or red flags that will augment the traditional machine learning classifications. So we've got a lot to get through. Hopefully this is interesting to everybody on the phone, and let's dive in. Before I jump over to a demonstration and start showing things, I want to emphasize one thing about Private Cloud AI. As I go through the demonstration, I'll be focused on the fact that our users of HPE Private Cloud AI have full control over their AI-powered applications. They have control over their data. They have control over the performance of the model that they're using, both in terms of quality and in terms of speed. And they have control over their costs. There's no surprise bills because you're paying per token or per user licensing fees. We generally emphasize best of breed open source tools that prevent lock-in. PCAI is delivered as a full stack, turnkey private cloud solution, deploys anywhere you'd like it. If you want to learn more, please reach out to somebody from HPE and learn about this. It's developed in collaboration with NVIDIA, so I'm going to be focused a lot on NVIDIA GPUs and NVIDIA software. Specifically for the details of what I'm going to be using during this presentation, for those on the phone from HPE or maybe the HPE partner community, I'm going to be using the solution demo portal, the Geneva CIC. So if people have an account on there, they should be able to see even the notebooks, like the data and the data sets and the code that I've written for this in the shared directory under a directory called Fraud Webinar. The last thing before I jump into these demonstrations is, probably the number one question that I get about PCAI. People see logos of all these different open source applications and they wonder what these things do. So I made a quick chart of what's included with version 1.6 of PCAI. I'm going to be using notebooks from Kubeflow. I'm going to be using the MLflow logging and registry. I'm going to be using MLIS, which under the hood uses Kserve, originally from Kubeflow, to deploy models. I'm going to show a quick demo of Ray if I have time. I don't really use it in here that much, just because the data set that I'm going to work with is pretty small. It's a bit of a toy data set. Same goes for Airflow, Kubeflow pipelines, Superset, Presto SQL, Spark, and a few of the NVAIE frameworks like Nemo Guardrails, Curator, Aligner, and Inspector. But hopefully that, or this slide, and if we share the slides, or maybe if you can click on screen, you can see the hyperlinks to some of the source code repositories and the documentation, so you can go read a little bit about these projects if you want to know details why we've chosen them. I think clearly from popularity on the right side, these are popular best of breed frameworks for the purpose that they serve on the cluster. So let's get into a demonstration so I can show you some of this detail. Part one of the demonstration is getting started with generative AI. Basically, in the environment, we pre-install an HPE developed in-house piece of software called machine learning inference software. MLIS is quite simply the way to download and run popular language models from places like Hugging Face or Olama.com. It is built on Kserve and integrated with popular runtimes so that you can get OpenAI compliant model endpoints, and developers will be able to just point their code to a new base URL and possibly provide a token or the name of the model. And that's all the configuration they'll have to change if they've been developing an application on top of OpenAI's ChatGPT APIs, for example. The features of this software, specifically is just implementing Kserve, which means it's going to run a model as a resilient API endpoint, so that if a GPU fails or a node goes offline or something like that, the model will automatically shift to a new GPU on the cluster if there's one available. And you can configure priorities of what to run on what GPUs based on, again, that priority. You'll be able to click to start and stop models and just share GPUs, generally speaking. In terms of sharing GPUs, you'll be able to create access tokens for users and groups to have permissions to use certain models in the environment, but maybe not use others. You'll also be able to auto-scale endpoints up and down to improve throughput with built-in load balancing. That means if one copy of one model can provide a certain amount of throughput on one GPU, but I need 2 times, 4 times, 10 times, 100 times that amount of throughput total from all the users in my user community, you can auto-scale these endpoints up and down from a load balancer to provide that aggregate throughput. And then, of course, you get things like logging and metrics for these endpoints. Okay, so let's jump over to a PCAI cluster and get started. Like I said, I am in the Geneva CIC from HPE, the solution demo portal. So for people on the phone who might be watching, you should be able to do this demo by clicking on Tools and Frameworks, on Data Science, and then on the MLIS tile here. When you click on MLIS, you're thrown into a space called Deployments. And it's basically the homepage for MLIS, where you should see which models are running on which GPUs. This Llama 3.1 NIM is used for a lot of different applications, so it should always be running. But depending on who's using the cluster while you're in there, you may see certain things paused and certain things ready. I have started this model called Pi4 VLLM, which is a open source model from Microsoft, which I'm going to use in the rest of the demonstration here. The most important thing that you get for a model that's running is an endpoint. This URL can be included in your code as a replacement for basically OpenAI.com. And it's with the /v1 endpoint, it's going to be compliant with OpenAI's API methods, assuming that you're running the VLLM or SGLang runtime underneath, for example. So if I click on one of these models, I'll show another piece of value in Pi4. One thing that we've got is the ability to configure who has access to the model. Right now, the user is Jordan Nanos, myself, and one of my friends, Dave Wright, has access to the model. But if I click Add New User API Token, since I'm an admin on the cluster, I should be able to select which model I want to create a token for, and then give this to somebody. So let's say, I don't know who's on the phone, but my friends Andy and Alex and Brody want to get access to this model. We should be able to configure a timeout or just leave it as no expiry and create a new token. So I've done that already for myself, which means that in API tokens over here under Pi4 VLLM, if I click that, I'm going to be able to copy away this token and use it with my Pi4 VLLM model. Of course, there's many ways to deploy new models. If you click on the packaged model section of the cluster, you should be able to edit some of these base model images and or package custom models. For example, if I click the VLLM base OpenAI, version 2 is Microsoft Pi 2, version 1 is Microsoft Pi 4. You should be able to see some things like which image, so which version of the VLLM runtime I'm running, how many resources I'm giving to the runtime image, like could have multiple GPUs here, configurable amounts of memory and CPU, and then specific environment variables if I want to tune VLLM parameters beyond just the port and GPU memory utilization, if I want to fix the context window of the model, or if I want to change the max number of batches that I can serve to the model, or the max number of sequences. All of these things can improve throughput or reduce latency, improve time to first token. That's what you do to set up a model. And then if you click over to deployments, you would create new deployment, select, well, I'll give it a name. We'll call it Jordan example. Select the packaged model that we want to deploy. In this case, my VLLM base. I'll go back to version 1 and deploy a new version of that Pi 4 model as an example while I'm doing this demo. So we'll leave that as is, and we'll show an example as it deploys. While that is deploying, I want to show how to access this model. There's basically two ways to do it. The simplest way is to, if you're on the Geneva CIC cluster, you can go to Shared Fraud Webinar, open Notebook 01. The simplest way is to pip install the OpenAI client in your notebook, copy in this token. Don't do this in production, but for testing in a notebook when we're on the cluster, hey, why not? Set that as variable. And then what I'll demo here is that, for example, this is my URL for the Llama 3.1 NIM. That's this one here, right? If I try to curl that endpoint, specifically the V1 models endpoint, which just lists what models are running, the cluster has permissions enforced. So RBAC says that I can't access it. However, if I pass the token into that endpoint, specifically in this API key field here, by setting OpenAI API key equals to token and then passing it into the client when I instantiate it, I should be able to send a request to the model, in this case, a completions request with the prompt HPE is a, and we'll get a response. Highly successful business with a long history of innovation and excellent customer focus. Awesome. Thank you, Llama 3.1, for the compliment there. We can also configure things in the prompt. So, for example, the default number of max tokens in the OpenAI client is 20. If I use 200, it might take a little bit longer, but I should get a longer response back from the model. There we go. Some more details in that response. I can also change from completions to chat.completions. Get some more details there. In this case, I have to pass in the role of user and then ask the question, describe HPE. This means that the model can basically provide an arbitrarily short or long response as it's been instruction tuned to provide, in this case, quite a long response. But one thing that we see is that the model's kind of presenting markdown. So I'm going to skip through here and do the same thing with a completions response, but instead of printing the response, I'm going to display the markdown file. This will take a second, but basically displaying markdown should show a nicer output. There it is. We get some bolding, the paragraphs are a little bit better, things like that. I'll scroll down, and the final demo I'm going to do here is just show that same token, EYJ, for example, that I grabbed from MLIS a few minutes ago with Pi 4 VLLM. EYJ. That's going to be used to access this Pi4 model. And I'll basically get the same thing. I sent a completion response. Panama is and then my response is tropical country. Therefore, its economy is highly predicted on weather conditions. Nice. I can also integrate streaming for this model, which is nice when I want to print stuff out in real time as the model's responding. You can kind of see that displaying there. So for those watching, this notebook is available. Please go build on top of it, deploy your own models, edit things. Hopefully it's useful as a reference of how to get started with the OpenAI client and OpenAI compatible LLMs within MLIS. And just for reference, I mean, there's a whole bunch of different things you can do just by changing this prompt. For those familiar, I mean, I could go into a whole bunch of detail on how to use LangChain and Llama Index to do, advanced patterns like retrieval augmented generation, like text to SQL, summarization. There's all sorts of different ways in which you can use these language models and kind of develop code right in one of these notebooks, which is running on the same cluster where the GPUs are running. Okay. So I don't see any questions in the chat. So hopefully everybody's understanding that. I'm going to move on to the second little part of the Gen AI section here, specifically with this imported framework. This is not a default framework from PCAI, but it's something that I've installed on the cluster. It's very
Jordan,
open web.
sorry. There is one question from Mark on the chat about the information you have just presented. He would like to know if he can get access to the platform you are presenting here to build his own demo or models and data sets.
Yeah, thanks. So I did see you respond to the question with the link to the demo portal, and I think that's
Yes.
that's the exactly right answer.
Okay.
People at HPE, this is, accessible. This environment I'm using is accessible to everybody at HPE. If you're an employee and HPE partners, we also have for, prospects and customers who are interested in using this, we also have a program called Hosted Trials. So please get in touch with somebody from an HPE sales team to get connected to the hosted trials environments in your region if you're interested in trying this out. But good to know that people are interested in trying it out so far. So,
Thank you.
yeah, thanks. Okay, so the next step is to work with OpenWebUI. I think working in notebooks is nice for developing code, but it's really not what people want to use at scale. They don't want to run code. Most users want a nicer web interface. So what I'm going to show now is this example imported framework, which is OpenWebUI. Put simply, OpenWebUI is a clone of ChatGPT in terms of the front-end experience. However, it preserves privacy by running locally. It is distributed as a Helm chart, and we install it on any PCAI cluster as the Helm chart. And the nice thing about it is that it lets you configure any OpenAI compatible or OLLAMA endpoint into the cluster. OpenWebUI is actually developed by the OLLAMA project, great group of people to work with. Some of the features here that I was kind of demoing in the notebook, but is much better in OpenWebUI, is that it saves chat history. It lets you have streaming markdown display. You can select multiple models from a dropdown, even within one chat. You can save prompt templates. You can build custom RAG pipelines with just click to upload files in the context or as the RAG pipeline. You can do more advanced things. I cover some of this on my YouTube channel if you search for OpenWebUI pipelines, specifically with a text to SQL project that was pretty interesting. If you want to learn more, obviously go read the docs, or I'm going to show a quick demo here, specifically how it works with PCAI. So from this dropdown, I've selected the Llama 3.1 8B instruct model. I can ask questions like, well, we can do questions or prompts. Help me write a blog post about the need for private AI cloud services. So like I said, streaming, markdown, and it's going to have a chat history that gets saved on this left-hand pane. You can see some of the things that I was chatting about in the past here, and some of the things that are being presented right here. Help me come up with 5 title options. Llama 3.1 has those title options. The cloud with a bulletproof veto, why private AI services are the future. Pretty nice, Llama 3.1. I can also change to Microsoft Pi 4 and say 5 more. And we'll see what Pi 4 says. There we go, 5 more title options. I can play with both models in the same chat. 5 more, but I'll say. There we go. Multilingual demonstration there for some of my international audience. So the nice thing about this, obviously, is that it's developed, you know, in a pretty nice custom way. But if I want to show how it works, and the admin panel, if I click on settings and connections, you need an admin account to do this. I'm basically passing in the exact same URL here from the MLIS section here, right? Deployments, Pi4-VLLM predictor, Jordan Nanos.pcai.hpecic.net. There we go. It's the same URL. And then it is the token that I was referring to earlier, EYJ, that I had created. So anybody who creates a new model in MLIS, looks like I actually created Jordan example, right? We could even demo that right now. For example, I turn off Pi 4, I click save, I go back to new chat, and now all of a sudden it's not available. But on MLIS, hopefully this works. I create a new user API token for user Jordan. Click create, head over to the API tokens section, copy away this token. We're going to paste it into my Open Web UI interface. Under settings, connections, create a new model with the correct base URL. This one being Jordan example. Verify it. Oh, I need the V1 at the end to make sure it's the OpenAI route. Click save. And now back over here in the new chat section, there we go. Microsoft Pi 4 is back and available to create. So in real time on this webinar, I was able to create a new endpoint, which downloaded container images, ran it as a inference service on Kserve on the cluster, created an API token, connected it to Open Web UI. That's really the experience that people are looking to get started with Gen AI on the platform. For now, I'm going to click pause on both of these endpoints so that other users can have access to those 2 GPUs. I don't want to be too much of a hog in my environment. Okay, moving on to part 2 of this webinar, which is using the PCAI environment for traditional machine learning. Hopefully, for those getting started with Gen AI, I'm going to put a pin in that. Maybe we'll do a follow-up about RAG or text-to-SQL or some of the more advanced patterns later. But for now, let's go back to basics and talk about the PCAI environment for traditional machine learning. So in order to explain how all of these different frameworks get used, I wanted you to take a problem statement and kind of pursue it end to end here. The statement is this: given historical data on fraudulent auto insurance claims, I'd like to train an AI model to detect fraud for new claims. The data is in a single file, but it's unprocessed. It's insuranceclaims.csv. So it's like an export from a SQL database or something like that. Some information in this database, in the CSV file, is categorical and some is numerical. For those maybe not familiar with machine learning, categorical variables are things like the state that the person was in, Ohio, Indiana, Illinois, whereas numerical values are things like their age. It's just a number. This data set is pretty small. It's just 1,000 rows and 40 columns. So it's a bit of a toy, but it's worth, I think it's descriptive enough to go through this project and be representative of some of the work that hopefully some users who are familiar with machine learning and data science might be doing on the PC AI platform. Specifically, we get categorical variables here like the occupation of the person, how long they've been a customer is a numerical one, and then the all-important yes or no fraud reported, our label that we're trying to predict going forward, our Y value. So I've got 6 steps in this approach. The first step is to pre-process the data. I'm going to handle missing values from the data set, drop columns that are unnecessary for predictions, drop highly correlated columns, encode the categorical columns with one-hot encoding, check for outliers, and then scale the numerical values to the 0 to 1 range. I'm then going to train some traditional machine learning models. I'm borrowing some code, as we do in the open source community, from a user on Kaggle who trained 12 separate machine learning models. And what I've done in this to demonstrate is wrapped the code in MLflow logging and registration code, which will kind of show what a traditional machine learning training job would look like when you connect to MLflow, and then the nice kind of outputs you get from that. So the use case or the frameworks that I'm going to use on the PC AI cluster to do this is quite simply a Jupyter notebook in Kubeflow, which if I jump back to PC AI is available either from the home page. I'm going to run from this Jordan test notebook, or if you click on notebooks on the left side. I happen to have one with 2 CPUs and 4 gigs of memory because I'm a bit of a hog on the memory on the notebooks. I get a whole 4 gigs, but the default notebook in PCAI that people get is 1 CPU, 2 gigs of memory. Everybody who creates a user account should get a default notebook like that they can access. You've seen me using this notebook already. It's this open tab over here. You just click, pop it open, and it pops open to a browser tab with your user authentication credentials passed through. I'm Jordan Nanos, authenticated to the cluster here. And on the notebook, I'm, jordan-nanos-hpe.com. Let me prove that with, there we go, jordan.nanos.hpe.com, right? This is inherited from our authentication provider. So the second piece here is to train some models. I'm going to do that again in the same Jupyter notebook, but I'm going to connect to MLflow for experiment tracking. The nice thing about Jupyter is not only do I get user permissions on here, you'll see when I jump through these notebooks that I'm actually working in my home directory here, which is kind of scratch and nobody else can see, but I've just copied them over to this shared directory so that anybody else on the cluster can pop open shared, and specifically it's shared /fraud webinar if you're looking for these 6 notebooks. Over time, all the code that I'm going to run here can be automated to run as a pipeline, which is where people might start using Kubeflow pipelines or Airflow in the environment. And as data sets grow in size to more than 1,000 examples, which is my toy here, we'll start exploring larger frameworks for like cluster side compute. Spark, Ray, NVIDIA Rapids, there's many ways to access more compute than what you have in that notebook, more than the 2 CPU, 4 gigs of memory that I just showed. I'm then going to deploy the trained models an API endpoint, build an example front-end application, and monitor the model over time. This can also be a pipeline, and because I just want to skip to it and show the results at the end before I walk through all the details, here's what the example application looks like for my demo. There's a cleanup script that runs in the environment, so I'm not sure this is still up. Okay, hopefully it is still up. No, it's not. Okay. Well, I will show possibly that deployment coming back in a second when I run import framework at the end. But the web interface is going to look something like this. Users get to plug in the number of months as a customer, the capital gains, the loss, the number of vehicles involved in the collision, basically the inputs that we see in the data set, click submit, and then have a model say fraud or not fraud. That's our end goal as I work through this here. Okay, so notebook number 2 in the environment here, you can see on screen, example notebook for HPE PC AI. Let's restart and clear and walk through this. As you read through, hopefully this is relevant, but basically I'm going to do some imports and read in the CSV file. This CSV file is here in the shared directory, and you should be able to see it. It's got what I was showing earlier. You know, an ID 1 through 1,000, I think, months as a customer, the age, policy number, and then all the way to the right side, our all-important last column, which is fraud reported, yes or no. That's what we're working with here. So some simple things for data prep. I'm going to replace NaN values with an in-place real NaN. And we'll just get some information where we can basically see that there's some missing values in here. Collision type wasn't filled in, authorities contact wasn't filled in, and property damage wasn't filled in for certain reports in the environment. If you want to visualize this, you can see a nice little chart using Plotly here, where there's the missing values for those individual items. So we can handle those in many different ways. I go through that in detail in the notebook. I don't think it's important to describe those details here. I'm also going to encode categorical columns, which basically means for a given column, instead of having the category displayed in the chart, what their education level is or what their occupation is, for example, instead, we are going to one-hot encode, so have multiple different columns, and then put individual ones and zeros in there for the given value. There we go. True and false for insured education level, instead of everything all as a category. The last thing that we do is check for outliers. The bottom here, I'm going to run through a number of these. And the important thing for outlier detection and for correlation is that this data set is basically being prepared for machine learning, because we don't want outliers or highly correlated values to skew the predictions that our machine learning models make. So that's it. That's data prep. This is something that could be done in a larger cluster. If, say, you've got 1 billion rows in the data set as opposed to 1,000, everything I just ran through is going to take a lot longer. And so you want to run on a cluster with dozens or hundreds of gigs of memory, as opposed to the 4 gigs of memory in my notebook here, and basically split up the data set, 100,000 rows to each worker in the cluster, run the job, return the results. I'll leave that as an experiment for future webinars or for the users to go through. But for now, I think the important thing that we want to show is modeling with MLflow. So one of the frameworks under data science in the platform is called MLflow. And I'm going to pop this open so that you can just quickly see the dashboard. MLflow is a way to keep track of the details of a given experiment that you're running through. And I've been running these experiments as preparing for this webinar. You can see 5 days ago, 2 days ago, I was running a bunch of different experiments, training different types of models with different frameworks like GBM, XGBoost, random forest, decision trees using the scikit-learn package, k-nearest neighbors. There's all sorts of different machine learning models that you can train for a binary classification problem like this. What I need to do is connect that notebook to this MLflow page. And so we've got a update token magic command in Jupyter, which means if you time out, all you need to do is run this update token, and then your auth running as jordan.nanos is going to be passed through to MLflow. So you can see the experience. You want the experiments you want to see and not see the ones that other people don't want you to see. For this demo, I'm going to change the name of this experiment and call it fraud demo webinar, which you can see is not in my list of experiments right now. But when I run an import, and then I create the experiment fraud demo webinar, experiment ID number 14 is created. And if I just refresh here, we should see, there we go, fraud demo webinar is at the bottom and it's blank. I have no machine learning experiments that have been logged yet. So the first thing that I'm going to do is, well, we got to set the experiment to match the name of what we just did with this mlflow.set experiment cell. And then we're going to start by running in the notebook. So quite simply, I can train a support vector classifier model with the sklearn package using these few lines of code from sklearn.svm, import svc, instantiate the model, and then fit it on the xtrain, ytrain pieces of my data set. I have done that a second ago earlier, where I split the larger data frame with pandas code into a training set and a test set. What that means is that if I run xtrain.info, I've got 750 of the 1,000 entries in here, but xtest is 250 entries. So we're going to train on the first 750 and then test on the last 250. It's a pretty naive split, but good for our demo here. So we're going to fit the model with a simple svc.fit and then use the predictions option there. So that runs really quickly on 750 examples, and we can quickly basically track some metrics. So in this case, I have defined an accuracy score, confusion matrix, and classification report, which are built into the sklearn package under the metrics method. So you call SVC train accuracy and test accuracy on the accuracy score metric, and then you print out something called the confusion matrix and the classification report. Importantly, these do something for fraud for those interested, which is they calculate the number of true negatives versus true positives and true negatives, or true positives, or sorry, false negatives and false positives, which is to say, how many times was it actually fraud and predicted as fraud versus not fraud and predicted as fraud? And then the inverse, how many times was it fraud, but the model missed it? And how many times was it not fraud and the model missed it? Optimizing for a certain model and tuning it to never miss any cases of fraud, but sometimes be too trigger happy, too many predictions of fraud, versus a model that every time it predicts fraud, it's definitely fraud. You can do these, assessments of different models and then use them in ensembles to figure out exactly what the accuracy is here. In this case, precision, recall, F1 score, these are tracked in these details. The reason I talk about all of that is what people really care about when they're training models. It's really not the svc.fit code that's so terribly important. I'll also show you a sweep, like a hyperparameter search in a second, where automatically determining the best model and fitting it there is not really the place where users spend a lot of time. Instead, we think they spend a lot of time looking at logs and looking at results. And so using MLflow to, for example, log the parameters that are used during training, if you set the kernel, the C, and the gamma, like these hyperparameters, and log them in here, and then you log the metrics like the training accuracy, the test accuracy, the weighted average of the precision, the recall, and the F1 score. All of this is going to be, if I run with MLflow start run wrapped around my code, this is now going to be stored in MLflow. If I hit refresh on the UI, in a much more like viewable and interesting way. So I can click on that individual run and then see some results in here. Like these are the parameters that I used. This was the training accuracy for the run. And, I can also see the artifacts for the run, specifically the model file, the Python packages that are required to reproduce this model, possibly for deployment or for somebody else to train with it. There's information about the model itself. There's lots and lots of different metrics. So this is like the simplest way that I can do this. But and as I go through this notebook, I train 12 separate models: k nearest neighbors with logging, a decision tree classifier, random forest classifier, a classifier using the Ada Boost package, a gradient boosted classifier using within sklearn, stochastic gradient boosting, and then shifting to using XGBoost as a package to use the XGBoost classifier. And then I think an important piece that I wanted to stop at, which is to use a grid search to search for the right hyperparameters and come up with the best estimator using the XGBoost package. It's not terribly important to look at the code, but I think you'll see, when I start doing these sweeps, it starts taking a little bit longer to run through these details. So in this case, the Ada Boost classifier package from sklearn is creating 60 candidate models in here, fitting them 300 different times with different parameters, and then taking the best one. Back down here, I think we've run through some of those, but back to the XGBoost sweep. Oh, it looks like it ran while I was scrolling, but I was doing the same thing. And then run with the MLflow logging. Try out the cat boost package if people are interested in that. Extra trees classifier back to sklearn, and then try out the LightGBM package, and finally get to a simple model evaluation. So if people are running in a notebook, at the end here, the result that people kind of look for is like which of these models that I just trained was the best. Without using, an AutoML tool or anything detailed like that, I can kind of get a comparison pretty quickly from this notebook showing which is the best model. And specifically, I'm doing this based on accuracy for the eval at the end. You could do it for a number of different things, but you'll see, you kind of need to have the knowledge to build these kind of reports right in your notebook to see, okay, yeah, the random forest classifier is what I want to take and go with for my production application because it's scoring the best on accuracy or something like that. But in MLflow over here, if I hit refresh, you'll see that I ran 13 different experiments across the 12 types of models with the different grid searches. And you can quickly, without notebooks are not reproducible. It's kind of the fundamental reason why they're good for testing. But MLflow it kind of makes them reproducible. And what I mean by that is that if I want to click to show columns here, I can quickly compare like F1 score, precision, recall, test, and train accuracy between these different models right here, right? And like quickly sort by, okay, top result for precision or top result for F1 score. And you can see random forest is good there. Looks like it's pretty good, but if for some reason I care about train accuracy and trying to determine overfitting it looks like I've had some bad experiments here. So maybe it's worth revisiting the LGBM model, working on it a little bit more because I could improve the disparity between test and train on this data set. The other thing that MLflow did, if people are interested, is it stored some artifacts. So when I was storing the classification report and confusion matrix, a lot of times people want to store graphs. And I think I included the code in one of these. Yeah, so if you use packages like matplotlib or Seaborn or Plotly or something like that, you can just create nice charts and graphs, and in this case, a confusion matrix to see what the results are for a given experiment run, and store those artifacts in the same directory on the MLflow side, right alongside all of the other experiments that you're running. Okay, so I'm going to take a breath here and stop with the notebook number 2. And it looks like there's no more questions in the, oh, sorry. I see there's 2 separate questions in the chat. Ravi says, is the platform providing weights and biases for data sets by default, or do you need to bring any other models for this? I'm not sure I totally understand the question. You could connect a notebook to a W&B dashboard. I think our recommendation is to use the local MLflow embedded in here, and we really just have experiments and models set up for the version of MLflow that's installed in the cluster. I think looking into curating data sets and stuff like that would need to be a follow-up webinar to go into more detail there. Not something I'm demoing out of the box today. And then another question, would users combine the results from many models to determine if X or Y model indicated fraud? We suspect fraud, or is it better just to find the one best models? Yeah, so at the bottom here, I include a voting classifier, which is a method to kind of let the best models combine or decide. Another term for this is an ensemble. So in this case, a voting classifier is again, it's a method within sklearn in their ensemble package where you get all of these different estimators to make a prediction, and then you basically try and take the best prediction from that. So I think in this result, because I've got some overfit models in here, it's not great. The voting classifier actually performs somewhat worse than an individual model by itself, but it's pretty good. It's scoring at 75.6 on the test set compared to 78. It's right there in the same class as the other top models in my model comparison. How do you avoid
Jovan, there is one additional question in chat. How do you avoid overtraining or bias?
Yeah, so this is definitely a skill of the machine learning developer, but it kind of skips forward to a slide, which, because the question's coming up right now, let's skip a little bit. Part 3, which I'll come back to, is building generative AI into this workflow. As part of the conclusion section, the recommendation that I provide to developers is to apply a framework called 4 Vs. So overfitting or underfitting or bias, there are all sorts of potential issues for a machine learning model, right? The framework that I use, that I think about to improve an application over time or improve the performance of the model, is the 4 Vs: volume, variety, velocity, veracity. So with volume, you need more data. In this case, more rows in the database will just improve performance. Generally speaking, more in the train set, more in the test set, more transactions is going to help. An alternative is more variety. So in some cases, we're dropping columns or we're processing data in a way where we're losing features that could possibly be useful for prediction. And so not only are more rows useful, but more columns are also useful. In other words, more features. The third one is velocity, which is to say recent data. So a big reason why machine learning models fail, this isn't for overfitting, but it's for bias, is because the distribution of the data or the user's behavior or customers has changed. Fraudsters started getting caught, so they started, committing fraud in a different way. So making sure you're always training on recent data is a way to improve performance in production. And then veracity, which is to say, if some of those labels of fraud or not fraud were actually wrong and I'm training on them, that's a problem for making predictions in production. And also making predictions about the test set, it can also be an issue. Like there could be many cases of fraud that were missed in both the train and the test set that skew results when cases that look like fraud are labeled as not fraud, trained on as not fraud, and then possibly predicted as fraud, investigated and found to be fraud. Is that an issue with the model, your data processing, how you're applying it in production? There's all sorts of ways to think about this at scale, but that's the framework that I take. Of course, simpler things like training more models with bigger hyperparameter sweeps and testing them is also a simple way to just improve and make sure you're getting the best performance. If you want to go into more detail, I did include a slide here with some pictures to kind of explain what recall, accuracy, precision, F1 score, what these things actually are in terms of true positive, false positive, true negative, and false negative for fraud or other binary classification problems. And then I used generative AI to explain drift. If you're interested in data drift, model drift, or drift detection methods, I asked Perplexity for some help, and I thought it gave a nice response. So there you go. And Mark, as well, refers to feature engineering. I should have definitely said that as well. Okay, I'm going to save the question from Bob in the chat for a little bit and try to get through the last piece of the presentation here, which is notebook number 6, building generative AI into a traditional machine learning workflow. We've seen interest in generative AI for fraud. Predicting fraud can be done with method number 1, which I just showed, structured data, take a classification model, fraud or not fraud. It can also be done with generative AI in 2 different ways. Take structured data, extract into a raw text file, use an LLM to predict it, which is what I'm going to show. Or the one that I'm going to recommend is, interesting for users to pursue or work with HPE if you'd like to reach out and get started, is method number 2, which is probably the more complicated one. Take unstructured data, use llama models, to, for example, or, ASR models or something like that to, for example, transcribe the audio that the person had when they called into the hotline to report the fraud, take a care agent's notes, take an email, a web form, something with unstructured text, summarize it, classify it that way with classification language models like BERT or with LLMs. This will enrich the data set and possibly allow the classification model to predict fraud or not fraud. Or you can use the structured data and have the LLM predict it directly and still use that enriched data set. So I'm going to focus on this one down here for the next little bit. I think I've got 2 minutes left. Hopefully people can stay on a little bit long. We could just record a little bit longer here if that's okay. Jenny? Yeah?
Yes.
Okay, great. So maybe before I get to this, just because I know we have the time. The other examples, which I'll update over time, I haven't finished the Kubeflow and Spark ones actually, are meant to just show how to connect to the other services on the cluster for people who have access to this solution demo portal environment. Basically, I will show the Ray one that is working. Just because I think, the question about like, how do we avoid overtraining and bias? I'm working with a toy data set right now, right? It's still relatively good for the predictions. 75% is like nothing to sneeze at, especially on binary classification with fraud, but it's a very curated, tailored, perfect Kaggle data set that's not representative of the work that people do. So you will need more data, generally speaking, and that means you will need more compute than the 4 gigs of memory that I have on this notebook if you want to run things in a reasonable amount of time. So I've got a Ray example which connects to the Ray cluster that is here. I'll pop open the dashboard just so we can see this thing run. And if you look at jobs, you can see me running a gem example, which I'm going to show in a second, and then Ray train. One thing about these Conda or these PCAI notebooks is that they come with Conda environments inside, which is to say I'm running everything in the base environment so far, but I'm going to run this notebook with the Ray environment. and I can switch the kernel. This base one is Python 3. That's what it's labeled as. Ray is what I've switched to here. Hopefully people who are familiar with Jupyter are going to be familiar with that. So Ray version is going to report I've got version 2.53. If, for example, I go back to the notebook that I was just running in and I report Ray version, no, not found. That's because I'm running with this different kernel, right? So I'm going to import Ray. I'm going to set the head IP to this Istio provisioned address, this like cluster local address that I have in the environment. And then I'm going to start running some stuff. So what I'm going to do in this test is I'm going to run a general matrix multiplication example, which just shows the performance of a given CPU or GPU. And you can see locally, that thing runs in 0.002 seconds for a matrix multiplication of shape 64, 64, 64 for the NMP values. If instead I define a function called RayGem, I'm going to run the same, gem function here. Matrix 1, matrix 2 is a NumPy array, do the dot product, stop the timer. But I'm going to submit it as a job. So RayGem here actually reads in RayGem example, which I've got as a small Python file in the local directory. You can read that here. It does the same thing. NumPy random runs the NumPy dot product, returns the resulting matrix, stops the timer. All this code in the notebook does is wraps it in this job ID and then submits it and waits for the session to finish. So here we go. I submit to the Ray cluster. It packs up everything in my local directory. It sends it to the cluster. It defines a certain amount of compute that's running, and it runs. Now, one thing about Ray, there, of course, like any other cluster side compute engine, there is some time to set it up, but you can see 0.002, I've got 0.001. I think I defined 8 gigs of memory for this job, or yeah, num CPU's 3, something like that. So it runs faster on the cluster. And if I go to my job here, the simple example has succeeded. There's lots more in this notebook. I run the different shapes that are common in machine learning for large language models. These come from the Llama 3.170B paper, and I'll kind of run that in the background as we go here. And you'll see a discrepancy of about 2 times, I think, for the specific compute that's running here. There we go. I've got gem example with 64, 64, 64 again running there. So that's a little introduction to Ray for those who are doing more data engineering work, prepping data. You may be interested in using that system. But let's get into generative AI for fraud. For this case, I'm going to pre-process the data in a similar way, not the same way as I did in the other notebook. And basically I'm going to visualize the same missing values, but I'm not going to drop a bunch of stuff that I knew wasn't useful for my machine learning predictions. Instead, I'm just going to kind of run everything right in the notebook. I think maybe I'm doing some local compute here and it's slowing things down. So I'm actually going to stop this. Let's see if I can interrupt the Ray example. And now I think I'm getting some imports done. There we go. Okay. Okay, so we still got the same missing values that I showed earlier. We're going to handle them and then come on down here. So the thing about this data set that I'm going to do is I don't really have a train and test set in this case in this traditional sense. What I'm going to do is I'm going to use a language model to predict the inference of fraud or not fraud. So I'm going to try and process the entire X data set, so everything but the fraud or not fraud values here, right? And I'm going to serve that to a language model wrapped in a prompt and just ask the model to directly predict fraud and see what happens. So let's drop some outliers and do the same thing. So the initial exploration is something like this. Let's take a single value from the test set, which is fraud, and then another value from the test set, which is not fraud, and wrap them, well, prep them as raw text, which is here. So that I have just instead of a pandas data frame, I just have the raw text in a nice little format with new line characters that my language model is going to be able to read correctly. And then I'm going to instantiate an OpenAI client the same way I did in the first notebook, pass in that token, and then define a full prompt. Based on the following claim details, predict whether this claim is fraudulent. Answer with a single word, yes or no. Do not provide any other text or descriptions. Then I'm going to pass in the claim for the prompt. And then I'm going to say, is this claim fraudulent, yes or no? So in this case, claim for prompt is a row from my data set, and it's being passed into the model with these new line characters. You can see it in here, right? This is my full prompt. So what I do is I create the chat response, and there it is. Chat response, no, not fraud, right? Now I did this for my claim for prompt, right? Claim for prompt was row equals x I log 0. Let's change this to 4. Do the whole same thing, and looks like it's saying no as well. Let's change that to 7. No. We're kind of getting no for everything. You can see a little bit of what's going on here. Now, if I go for 10, no, again. So what I'm going to do is I'm going to basically try and do this at scale. And I am still kind of currently working on this. The models really don't perform that well. But I want to point out something here, which is that for just 1,000 examples, you saw how quickly I could train the individual like models in the machine learning notebook, the first one. If I'm trying to run forward passes, just inference with this LLM endpoint for 1,000 examples, here's 10 sets running, right? 10 examples. It took, a decently long time, right? So if we go to 1,000 examples and I time this and I specifically batch it up, where those 10 examples kind of run asynchronously against the endpoint, and I take advantage of the endpoint's throughput, what I can do is basically perform a full run with 1,000 samples in a shorter total time. So in this case, I'm processing 10 samples in 16 seconds. I may be able to process all 1,000 samples in, a shorter amount of time. But the point is that training on 1,000 samples was happening in milliseconds for the machine learning model. Running inference with this language model is going to take 5 minutes to 10 minutes here. I haven't actually timed it, but that is the example that I was trying to show to a number of customers who are wondering, basically, how do I start using generative AI models with a traditional machine learning workflow, right? Basically, what you need to do is prep a tabular data set into text and send it in with your prompt. And then you just start changing the prompt, right? You start changing things like, answer with a single word only. Do not provide any other text. You start, doing prompt engineering, the way that in the past you may have been spending time as a machine learning engineer doing data engineering, right? Okay. So while this is running, I want to show one last thing, and I've left it to do here because I need to figure out how to do evaluations and running out of time on this webinar. So last thing is deploying that application. I kind of referred to it in a previous slide here in this one. And I just like to show what it looks like. This is the same process for any Helm chart. If you have a front-end application that you've developed as a Helm chart, you can deploy it on this same Kubernetes cluster that's running all of the other services. It's just going to grab some CPU and memory and some storage, and it's going to run. In this case, I'm going to call this fraud webinar demo for the PCAI fraud webinar with the dev community. And just nicely for the UI, I'm going to say I'm going to put it in the data science category. I'm going to grab an image from my local directory here on my laptop. Nice HPE logo. And you can upload any Helm chart that you've packaged as a tarball. I know that I already have one here, which is fraud demo 0013. And importantly, I can only run this in my namespace. So maybe also a demo of cluster permissions in here. If we have kubectl installed in the notebook, so you can see what pods are running in your namespace, what services, deployments, things like that. But you don't have permission to every namespace. What you do need is the actual name of your namespace in order to make sure that this framework goes into the namespace correctly. So I will do that. I could configure some values. In this case, I've just got this fraud demo container that I'm running. And I'm going to click submit in here. That is really all it takes to import a Helm chart onto the cluster. Obviously, there are some details about the ingress service YAML file that we need in there. Things need to be named correctly to work with the cluster, but quite simply, this is pulling a container. I can go back to my cluster here. I can kubectl get PO. We can see fraud demo. Looks like it's running 18 seconds ago. We can get logs of that container in the pod. Logs without the get. Looks like nothing's coming up right now. Oof, I didn't do something right. Interesting. Well, let's see if it still gets a URL and deploys correctly here. The point that I'm trying to demonstrate is that we can import a Helm chart, even though there's an error in my my application as I've been developing it over time here. I still get the URL from my Istio provisioned. It is ready and available. And if I write my code better correctly, I would have that that front end that I was testing locally. All right. Well, live demos almost went well the whole time here until the very end. Let's finish with something that was working here. So yeah, one thing about this these requests here is that you want to be able to run against these models if they run out of throughput. And kind of see this. I'm running a big batch of inference against the same model that I'm running for chat in the environment. So maybe the last demo for the webinar here today is to go back to OpenWebUI, go back to this Llama 3.1 model and say, write me a blog post about fraud prediction with AI. You should see that this is a lot slower to get an actual response. The time to first token is really slow. And that's because there's literally 1,000 requests asynchronously being sent from this client that I've instantiated in this notebook here to the same endpoint that I'm trying to use for back and forth chat here. So I started today with the demonstration saying, hey, people want control over model endpoints for performance in terms of quality and speed. They want control over their data sets because they want to maintain privacy, and they want control over their costs. HPE PCAI in general is what's going to allow people to start and stop model endpoints to power generative AI, and allow people to start and stop notebooks to develop machine learning applications, start and stop RAY jobs to develop data engineering workflows at scale, track experiments with MLflow, write pipelines into Kubeflow, Airflow, develop dashboards in Superset, prep data in Spark. It is meant to be a comprehensive application that covers, or comprehensive, really platform as a service offering, right? Where we are including the hardware, the software, and the professional services to get this running, get the experience that I've demonstrated today available to your users in your local environment as you see fit. So I'll leave you with that. Why HPE for generative AI? We provide users with control over their AI applications wherever you would like to run them. So that's all of the live demo that I have. I'm going to leave a little thank you on screen here. You can check out some more demo videos that I have on YouTube, follow on Twitter, X, GitHub, LinkedIn. While I'm responding to some questions in the chat that I saw queuing up here, I would love if everybody would respond to this poll. We covered today LLM serving and traditional machine learning workflows at a pretty high level. Hopefully it was a good run through of the different services in PCAI, but we'd love to do more. And so if you could provide some detail to us just by either specifying, what you'd like to see in future webinars, or by answering what individual, thing that we kind of have planning you'd like to see, like, hey, I'd like to see an LLM powered chat application or a coding assistant. Please answer that poll. And yeah, thank you for that. Okay. Let's look at some questions here. So everybody says thanks. Thank you everybody for taking the time to listen. I think it's been like an hour and 15 minutes. So yeah, I'll start taking some questions here. So first one that I'm going to answer from Ravi is what is the roadmap to fit PCAI for edge? Any thoughts on that? I think if you want a PCAI cluster at the edge, we should explore a smaller developer kit, possibly just a single server. But it always depends on your definition of edge. I've got a lot of people running edge data centers with 3, 5, 7 server clusters, telco rack, retail store, manufacturing site. I think there's lots of options to run all of the services that I've shown here at the edge. Our starter small PCAI cluster is a single rack, which can fit in some edge sites. So depending on definition of edge, I can probably do it now, but there would be some work to shrink down all the different services I described today to fit on just a single server, for example. Thank you for the responses. Looks like LLM-powered chat applications and coding assistants are tied in the responses. So appreciate everybody who stayed on and gave those responses. So another question, is this a life insurance or gen insurance set that I'm using, data set? Yeah, so it's a auto insurance claims data set. If you look at the slides, like based on collisions, if you look at the slides, this comes from some user on Kaggle, Bunty Shah. So you would be able to click that link and see the data set. Defensive cyber operations from Scott. Yeah, let's have a conversation offline about doing this for truly offline workloads. I think there's work that you can do to make this work in a secure enclave and not download container images or models or data sets from a public registry. In this case, everything I've showed, just to be clear for some people maybe, everything I've showed is a PCI cluster that is private to you, but still connects to the internet, which is to say, if your user goes out and decides they want to run a VLLM, runtime with an arbitrary model from Hugging Face, like they're going to be able to download and run it. They're going to be able to pip install. They're going to be able to Kaggle dataset download or something and work with that. Hugging Face, CLI. Like, if you want to truly lock that down, let's have a discussion about running that in a secure environment, through proxies or just totally air-gapped offline. I think that's it. Appreciate the great feedback in the chat. Hopefully everybody thought this was good. Seems like we did. Any further questions, obviously feel free to reach out, but thank you for taking the time today.
Thank you very much, Jordan, for your great topic and demonstration. Thank you everyone for joining us. So talk to you soon.
All right, take care, everyone.